Dr. Johnson, thank you for being here with us today on such an early occasion after your successful landing of the Perseverance Rover. I am sure that you're very proud of all the work that you put into the rover and the time in which you spent with other people in working with that rover.
Thank you for having me. Yeah, I'm very happy about how it turned out and very relieved after working so long on it to actually have it be such a big success. So thank you for having me.
So can you go into depth about your official job title at JPL, the research you did at JPL, and your initial aspirations of becoming a JPL engineer?
Yeah, so my name is Andrew Johnson, and I am the manager of the guidance, nav, and control subsystem on Mars 2020. And part of that subsystem is the lander vision system, which was recently used on the landing on Mars. I started at JPL in 1997, probably about 23 and a half years ago. I came here straight out of PhD at Carnegie Mellon University. I have been doing research and technology development the whole time that I've been there. Mostly working on problems related to landing on either planets or comets and asteroids. And my background is computer vision, so it's a part of computer science where you process images and figure things out from those images. And there's a couple problems we're working on. One of them is using the image to figure out your location or your position relative to a map. And that's basically what the lander vision system did. So what I really enjoy about JPL is that you're able to develop something new, a new technology, and then also work on it on a flight project, on something that can go into space and be used for something. And so I like to follow that whole cycle where you take something new, a brand new idea, and just take it all the way through basically from cradle to grave. Idea all the way to landing on Mars or to being used on a spacecraft.
Can you go into depth about your interest in the machine and computer vision?
Right. So when I was in grad school, I was in the part of the university that was focused on using sensor data to understand the world around it. And that's basically what computer vision does with camera images. There's different pieces, different problems to solve. There's a lot of computer vision used in autonomous cars and also in just regular cars when it's looking to see if there's a car in front of you might run into. That's actually an application of computer vision. Uses cameras and stereo vision to figure out where things are. Another area that I work on is using a more exotic sensor called a LiDAR, which is something that uses a laser to figure out how far away things are. And you can actually have LiDARs that are like cameras. They take pictures and they tell you how far away every pixel is in the image. And I, in graduate school, used that type of data to do object recognition, to figure out what the LiDAR was looking at. Was it a wrench, a toy, this or that? It was that was the problem that I was working on back then. And then when I came to JPL, I had to sort of tailor my studies to the problems for space. And so that area that was sort of ripe for study was landing type of applications.
I understand that the rover was launched in July of last year. So can you take us through the entire process of how you designed, tested, and launched the Perseverance Rover?
Yeah, it takes a long time. So I started on the project in 2013. That was a little bit after it really started up. And then you go through some design cycles where you figure out what you're building and sort of what performance it needs to have, how big it is, what the mass is, how designing the computer and all the pieces that go into it, designing the camera. So you do that for a while, and then you actually start building the hardware. We do that also at JPL. We have labs and facilities that build computers, and we also have other places where we can get sensors and buy them from companies. You put it all together and you attach it all up, and then you test it a great deal. And then once you've tested it, you deliver it to the spacecraft where it puts together with all the other systems. And that's done at JPL first, and then it's done at Florida. And then it's put on the rocket and launched into space. So it's a lot of development, but there's also a great deal of testing, because the first time you use these systems, they have to work perfectly.
So can you, I understand that you worked on the Curiosity rover as well as the Perseverance rover. Can you tell us how the software for the Perseverance rover differed from the Curiosity rover?
Well, there's a lot is the same and a lot is different. So I think in general the mission Perseverance inherited a lot of capabilities from Curiosity, but we added things on top of it. And so for landing, we added the lander vision system and terrain relative navigation to land us in somewhere that was very hazardous, but find a safe spot within that hazardous region. So that's something that was added to the landing sequence. And then we also, for the rover mission, Curiosity, which is the part I worked on Curiosity, was the rover. It actually can't do things very quickly. It drives, Perseverance and Curiosity's wheels turn about the same rate. But on Curiosity, it has to spend a whole lot of time thinking about what it's looking at, because it doesn't have a really good computer to do that thinking. And we built a new computer that allows that thinking to be done more quickly, and that's what we have on Perseverance. So it can actually drive around rocks and things like that much more quickly. So those are additions to the basic infrastructure that the rover provides. The way it gets power is the same. It has 6 wheels. It's very similar in those aspects.
Although you mainly worked on the landing software of the rover, can you go into depth about the collaboration you had with other teams in implementing an efficient rover?
So we, my area is guidance, nav, and control, but we have to interact with other parts of the spacecraft, like the mechanical system. So our camera that we use is attached to the rover, so they designed a bracket for that. They also, we have to know where the camera's pointed, so we have to talk to them about how much the rover might move relative to the other piece, which is the descent stage. So there's interactions there. We have a computer of our own, but we have to interface to another computer that's in a different subsystem. So there's data signals that go back and forth, and messages and data and things like that. And so we have to make sure that we both agree, that the two teams agree on what those are. I could go on and on. There's thermal management systems, and it's very, guidance, nav, and control touches a lot of different pieces, because it's like the autopilot of the spacecraft. It's telling it where to go and how to get there, and and figures out how accurately it's going along the way.
Within this entire development process, can you explain how COVID-19 affected the process?
Well, absolutely, it affected our mission quite a bit. So when the pandemic lockdown started, we had just started integrating things at Kennedy Space Center in Florida, and we didn't have all the hardware there yet. So that team had a deadline, because you can only launch to go to Mars every basically every 26 months. And so we had a deadline. We had to launch in July and get things done. And so we really needed to prevent COVID from slowing things down. And so that team became a small team, and the team was very closely monitored their contacts with others. We didn't visit Kennedy Space Center as much. Only critical people could visit, and just to keep the contacts down low. And so they actually were able to do the integration, and they delivered it on time, and it launched on time, basically. And for us, back in JPL, all the interactions you normally have in a conference room now become interactions over, Zoom or WebEx, the tools that we use, the virtual tools for interacting. So that actually worked out pretty well for us. We're used to having other people from across the country in our meetings, so we actually have those tools going already. So that wasn't that big of a deal. and we didn't have much. There wasn't much impact to our team due to that.
Can you discuss the process of transporting Perseverance from JPL to Cape Canaveral?
Well, I can tell you what I've seen in pictures. Basically, we put it all together, the whole spacecraft, just put it all together and test it in like thermal vac chambers and things like that. So it's completely assembled at JPL. But then when it goes to Florida, it's taken apart a little bit and transported there basically on a giant plane that can fit it in there. And then it lands, and then it goes on a truck and to the clean room. So it's just because it's such an expensive thing, it has its own plane, and that's how it gets there.
Can you describe the tension of the 7 minutes while you're waiting for it to land? At what period of the landing does the lander vision system begin to lead Perseverance into the landing site?
It was very tense for me because I had to monitor things and make sure things were going well and announce if they weren't or weren't. And so it was very intense to look at all the data. I had some computer scripts written to show me specific things I was looking for. And when the one thing that I saw that was the most important thing for me to see was when the lander vision system got a position estimate. And that I called out over the intercom, LVS valid, and that's when I knew all these years of hard work had paid off because my system worked, at Mars. So, but we practiced, and so the interactions that we had on landing day, we had already practiced a couple times, and so they do that to make it so you can be comfortable in that situation. I almost felt like the practices were more intense than the actual thing. So, but it was great when it was over and we had landed safely.
So the Perseverance launched, I believe, landed, I believe, last week. Is that correct? So since then, what new developments or research does the rover landing bring to space exploration? Does this open new avenues to potentially similar projects?
It does. So you know that the Perseverance is the first part of Mars sample return. So it's collecting samples from the rocks and the soil that's at the landing site, and it's going to put them in these little test tubes, and then those test tubes are going to be put in a rocket, and the rocket's going to be launched into orbit, and a little ball is going to come out with the samples in it, and it's going to get picked up by another spacecraft and brought back to Earth. So in that sense, it's, the mission leads to these other missions, of course, but also the new technologies that we worked on can be used for landing on other places. So there's obviously the next Mars mission that goes and gets the samples, will use the technology we developed to land safely, lander vision system. But you could also apply it to landing at the moon, and we have some things related to, working on that. NASA wants to send people back to the moon, and so you want to put them at a very specific spot, and so the technology we've developed can be applied to that. And then there's also other places in the solar system, like Enceladus, which is a moon of Saturn that has an ocean all the way around underneath an ice cap. And so we want to go there to look for life, or look for signs of life, I guess is the right way to say it. And also Europa is a moon of Jupiter. It's a bigger moon, and it has a global ocean also. Very interested in going there. But both of these places are really rugged. And so you have to have technologies that allow you to land safely and not crash.
As an engineer at JPL, what advice would you give to students at high school or at college that also want to be a JPL engineer?
Well, there's the obvious things about the types of classes to take, and we have a lot of engineers there. There's also a lot of scientists, but it's really in science, technology, engineering, and math type classes. And then also in college, doing a degree in that area. JPL High has a lot of PhDs, a lot of masters, so getting a PhD or master's is increases your chances of working there. I just say, like in everything in life, you need to work hard and be persistent and not give up. Everybody else is working hard, so there's competition. So do your best, and that's pretty true for any field, I'm sure. But once you get to JPL, it's an excellent place to work, and it's really all about the people that work there. That the team are just really, there's a lot of respect and trust and just a lot of knowledge captured there. So you can really rely on the other people that work there if you have problems, for example.
Of course. Well, thank you, Dr. Johnson, for taking the time to interview with us.
Thank you.